Okay, I think we're live. Okay. Okay. We'll wait a bit more to see if anyone else shows up. Hello. Hello, chat. I'm not eating anything. I don't know. What? Yeah, okay. I have a bowl, but it's empty. I'm not eating anything. All right, all right. We'll get started then. Let's see. So the plan is to go over some probability stuff, and then we can, and then I'll probably go over a SL test. All right. Okay. I think this is it. Okay, so I'll just go over the ones that are circled, and chat, if you guys have any questions, just send them. I'll try my best to look, but like I only have like one screen right now, so I can't see the full thing. So okay. So this is pretty simple probability. So an inspector at an egg farm routinely inspects a dozen eggs from each consignment. The inspector records the number of broken eggs as part of the quality control process. Describe the complement of the event. So, complement is always like the opposite. Oh, and I can share this so that you guys can see. You guys can join this whiteboard if you want. So the complement always means the opposite. So in this case, the complement of the event, at most one egg is broken. So at most one egg is broken means that there's either 0 eggs broken or there is 1 egg that is broken. So the complement of this would be not 0 or 1. So that would mean 2, 3, 4, 5, all the way to a dozen, which is 12. So that would be the complement. So basically, the complement of the event, at most 1 egg is broken, is 2 to 12 eggs are broken, or at least 2 eggs are broken. Oh yeah, if you have any questions you want me to explain, you can DM me on Instagram. You can just send it. Okay. Okay. All right. Is that okay? I can't read that, but why is this so blurry? What? There you go. Okay. This time it worked. Okay. So, a certain experiment has only 4 outcomes. The probability of each outcome is twice the probability of the preceding outcome. What is the probability of each outcome? Okay. So, a certain experiment has only 4 outcomes. So let's say that the probability of the first outcome happening is A. Okay, so that's first outcome, second, third, and fourth. So the first outcome would be having probability A. Now the second one has to have twice the probability of the preceding one, so that's 2A. Next one would be 4A and 8A. So as with all probability questions, since they told you that this thing only has 4 outcomes, we know that if we were to add up all the probabilities, it has to sum to 1. So this gives 15A equals 1, and A equals 1 over 15. So you can calculate each of the outcomes from that. A store advertised a sale in the newspaper and on TV. A survey of 200 customers indicated that 60 learned about the sale from the newspaper, 50 from TV, and 30 from both sources. What's the probability of each event? So a randomly selected customer saw the advertisement in the newspaper and on TV. So when it sees both the advertisement on newspaper and TV, we need to take this number right here. So that's 30. So that would be 30 out of the 200, or 3 over 20. Okay, so I'll run through sections 5 and 6. Okay. Alright, so we'll run through section 5 and 6. So, 2 cards are drawn without replacement from a shuffled deck of 52 cards. What is the probability that the second card is each card? Okay. So, in these kind of questions, especially when it's asking for the second card, we need to do a casework on what card it is. So, we need to separate it into 2 cases. So 2 cards are drawn without replacement. So we're going to draw one card and then another card. Let's say we're doing part A right now. So let's say we draw an ace on the first turn. So we draw an ace on the first turn, and then we have to draw an ace on the second turn. Or we don't draw an ace on the first turn, but we draw an ace on the second turn. So these are the two cases. In the first case, if we draw an ace on the first turn, there's 1 out of 52. Then, on the second turn, we have to draw another ace. Now we already, or not 1 out of 4 out of 52. On the second turn, we already drew one of them, so that would be 3 out of 51. Now for no ace, the first one would have probability 48 over 52. And then this would have probability 4 over 51. So you would multiply these two together and you add them up. And that would give you an ace. A club, basically the same thing. Red card, same thing. Red face card, yeah, pretty much the same thing. You just want to have one, you just want to do casework. So these are the two cases here. Blackjack, Queen of Hearts. I'll do the last one just as an example. So what's the probability that the second card is the Queen of Hearts? Well, in this case, the Queen of Hearts has to be drawn on the second card. So that means we can't draw the Queen of Hearts on the first card. So essentially, we have 51 cards to choose from the 52. Then we have to choose the Queen of Hearts from the 51 cards left after choosing the one from the first step, and that has to be the Queen of Hearts. So 1 out of 51. Then you multiply them together. And in this case, these cancel out, and you just get 1 over 52. My mic is pretty nice. I'm not. This is just my laptop mic, so. All right. There are 100 boys and 120 girls in the grade 12 year. 20 boys and 30 girls have no siblings. A student is randomly selected. What is the probability that the student has no siblings? Okay, so a student is randomly selected from the total group, and in this case, we need to recognize that we're selecting from the entire population of 220 people. 100 boys and 120 girls. We're going to choose, and we want to find the probability that the student has no siblings. So we have to choose 20 of the boys or 30 of the girls who have no siblings. So that would give 5 over 22. And in this case, question B asks, a student is chosen who has no siblings. What is the probability that the student is a girl? So in this case, we already told that the student who is chosen has no siblings. So we're told, and in this case, the total population that we have changes. Because in this, now we can only have, our total population is limited to the 20 boys plus 30 girls that have no siblings. Because a student is chosen who has no siblings. Then, so the denominator in this case would be 20 plus 30. Then the probability that the student is a girl would be 30 out of that. And in that case, that would be 3 out of 5. So in this question, it's very important to determine what goes in the denominator and what you're actually choosing from. So in part A, we're choosing from the entire population, but in part B, we're only choosing from the student who have no siblings. go over. Oh, right. So I'll go over some more binomial questions. Okay. So section 6 is talking about the binomial distribution. So with the binomial theorem, it's very important to remember the general form. So that's a plus b to the power of n equals sigma I equals 0 to n choose, or let's do k from 0 to n choose k, a to the k, b to the n minus k. So this is a very important form. Now these are mostly calculator questions in which you just plug it into the calculator. So I'll do question 5. The probability of rain for any day in March is 70%. What is the probability that it will rain at most 5 days in a week in March? So what this basically means is we want the probability that it will rain once, or it will rain no days in March. It will rain 1 day, 2 days, 3 days, 4 days, and 5 days. So essentially, since they told us that the probability of raining on any day is 70%, this is pretty much a binomial distribution. So if you can plug this into your calculator, so that would be binom CDF, since you're summing across 0 to 5. And I'm not quite sure the order, but I'll double check. Can I do trig and identities after? Yeah, sure. I can go over those. So binom CDF, let me just check. Distributions, binom CDF. Okay, so the order, it's trials. So it's trials, P, then X value. So in this case, the trials, the total number of trials, which is the number of days in March, will be 31. Probability is 70%. And X is our target, so that's going to be 5. So if you plug this into your calculator, it will give you the answer to problem 5. Now, let's say, for example, this question was asking for like the complement, right? Let's say it was saying the probability that it will rain at least 6 days. Oh, this is in a week, sorry. So that wouldn't be 31 then, that would just be 7. So binom CDF, 7, 70%, 5. So let's say the question was asking for the complement of at most 5 days in a week. So that would be at least 2 days in a week. Or it will rain on at, okay, the opposite of, or the complement of the probability that it will rain at most 5 days in a week is that it will rain at least 6 days in a week. So that's 6 or 7. So if you want to calculate 6 or 7, you can just take 1 minus this. So always in the test, keep in mind which one, calculating the complement or directly calculating it, which one is easier, and then decide which one you want to do. Okay, I'll go over some more binomial questions. Yeah, I'll do some binomial questions. Like determining coefficient. Yeah, it's just what I'm about to do. So, rotate this around. How do I rotate this? You rotate this image. Oh, there we go. Okay. Okay. First question says, find the coefficient of x cubed in the expansion of x plus 1 over x to the power of 5. So, definitely very important is you have to remember this formula. Whether you understand it or not, you have to remember it. So, or I think you get this on the formula booklet, but make sure you know how to use it. So, question 1 says coefficient of x cubed in the expansion, x plus 1 over x to the power of 5. I can rewrite this as x plus x to the negative 1 to the power of 5. And now this is a very clear format where I can use the binomial expansion. So this would be sigma k from 0 to 5. 5 choose k, x to the k times x to the negative or 5 minus k, or not 5 minus k, negative 5 minus k. Or I'll write it at this, negative 5 plus k in brackets like that. 5 minus k in brackets like that. That makes more sense. Right, so this simplifies to k from 0 to 5. 5 choose k, x to the k plus negative 5 plus k. So I'm basically combining everything. So sigma k equals 0 to 5. 5 choose k, x to the 2k minus 5. Now I want the coefficient of x cubed, so I'm going to set the exponent here to 3. So 2k minus 5 equals 3, and that would give k equals 4. So the coefficient of that would be just simply plugging k equal 4 into our combination, and that would give 5 choose 4, which is 5. Alright, so you can pretty much do all these questions here using a similar example or a similar method here. Can I go over combinatorics? Yeah. After this. Yeah. If you have any questions, just send them to me. You can send them to me on Instagram. Right, I'll do one more. So I'll do question 6. So show that the coefficient of x squared in the expansion of 2 plus x times 1 plus x to the n is n squared, and that the coefficient of x cubed is that thing. So in this case, I'll write it out first. In this case, when you approach this problem, you have to see that, well, first of all, the power of n only acts on the 1 plus x. It doesn't actually do anything to the 2 plus x. And 2 plus x is essentially, well, in our first step, we're not really going to care about it. And also you want to keep in mind what the question is asking for. So in this case, it's asking for the coefficient of x squared and x cubed, right? So after, let's say, I were to expand 1 plus x to the power of n, I only really need to care about the coefficient, or only really need to care about the terms up to x cubed. So I would have something like a0 or a1x plus a2x squared plus a3x cubed, or plus an a0 term as well. So I would have something like this after I expand 1 plus x to the power of n. And of course there's infinitely many terms following that, but I only care up to x to the 3, because it only asks for x to the 3. And when these terms multiply by something in here, right, the exponents can only get bigger. And once it gets past x to the 4, we know that it can't go back to x to the 3. But it's important to know, to take note, if, let's say you expanded this, if after multiplying something in here, the exponents can actually decrease. In this case, it can't, because you have an x to the 0 and an x to the 1. Basically, when you multiply stuff together, the exponents can only increase. So what we're going to do is we're going to expand 1 plus x to the power of n, but we're only going to write up to the x cubed term. So I'll copy 2 plus x down first. Then you have, using the binomial distribution, n choose 0, 1 to the power of n, x to the power of 0, plus n choose 1, 1 to the power of n minus 1, x to the 1, plus n choose 2, 1 to the power of n minus 2, x to the power of 2, plus n choose 3, 1 to the power of n minus 3, x to the power of 3. And there's more terms after that, but I don't really care, because it's not going to influence the coefficient of x squared or x cubed in the final result. So once again, 2 plus x stays here. This first term is just 1. The second term is nx. This third term is n times n minus 1 over 2 x squared. This term is n times n minus 1 times n minus 2 over 6 x cubed. Once again, plus dot dot dot. Now we can expand what we have here completely, and then we can find that the coefficient of n squared is this, and the coefficient of x squared is this, and the coefficient of x cubed is this. I'll finish the expansion just so you guys can see. So I'll distribute 2 in first, so 2 plus 2 in x plus n times n minus 1 x squared plus n times n minus 1 n minus 2 all over 3x cubed, plus I'll distribute the x in, x plus nx squared plus n minus 1 over 2x cubed. And I don't really care about x times the x cubed term, because that's going to give an x to the 4. So plus dot dot dot. So combine like terms, 2 plus 2n plus 1 x. So I have this, got that, plus n times n minus 1 times n. So that's n squared minus n, expanding that, plus another n, which is here. So now I got everything, x squared. Same thing here, I have n times n minus 1 times n minus 2 over 3 plus n times n minus 1 over 2 x cubed. So don't really care about these terms, but the coefficient of x squared is n squared, x squared, and the coefficient of x cubed is, let's see, well, you can do the expansion, but you should end up with what it's up here. over 6. All right. So that's it for binomial expansion. If you can get these questions, I think you should be good for the test. All right. So okay. Let's see. Okay. So Iris asks if I can do trig identities. So what identities do you want me to go over? Now we'll get to counting in a bit. Okay. Well, that helps a bit. Okay. Okay. You don't even know what a trig identity is anymore. Okay. I'll pull up the IB formula booklet to see what you need to know. Should be this one. Right, so geometry and trig. Okay, so law of sine, law of cosine, definitely need to know that. Area of triangle. This one's pretty important as well, but it's just an extension of law of sine. This Pythagorean identity, double angle identities, reciprocals. Okay, Pythagorean. Yep. Compound angle identity. Okay, this is pretty important. Double for tan, and those are vector stuff. Yeah, and that's okay. So not too bad. Okay, I'll start with I'll just start with the sine law then. So given a triangle, say like that, sides or angles A, B, C, sides A, B, C. Sine law states that A over sine A equals B over sine B equals C over sine C. And this is not very difficult to prove. You can just draw a height down. You know, this is sine B times B would be this height here. So is sine C times C. So it's just a way of symmetry, and you can get A over sine A as well. Cosine law. So this one works with all three angles, but I'll just write one. So this one says C squared equals A squared plus B squared minus 2AB cosine C. So A and B and the angle between the sides, and then the third side would be c. Now this is pretty symmetric, as you can see. This is also an extension of Pythagoras' theorem, because when cosine c is 90 degrees, or when c is 90 degrees, cosine c is 0, and this term just goes away. And then you just get c squared equals a squared plus b squared, which is exactly what happens if you have like a right angle triangle, right? Right. Area of a triangle. Okay, so this one, we know that area of a triangle is always just, so I'll say S equals base times height over 2, right? So in this case, base is A, height, let's call this point D, actually. So would be times AD over 2, and we know that AD is also, or sine C times B, correct? So B times sine C would give AD, so A times B times sine C over 2. Basically, if you have two sides, you find the sine of the angle between them, multiply all three together, then divide by 2. That's the area. SL doesn't do compound. It's going to be on your final. It's going to be on your final. Well, you never know. Just because they didn't go over it, you might as well know it. So, you might as well know it for the... Oh wait, do the SL kids get the HL formula booklet? You guys all get this one, right? Like you guys get the full booklet. Yeah, you get all of them, right? Yeah. Yeah, so if it's on your formula booklet, there's no reason not to know how to... I mean, like, if it's on your formula booklet, you might as well just know how to use them. It's just a formula in the end. Identity for tangent, that's pretty self-explanatory. Pythagorean identity? Okay, so... going to the unit circle for this one. Say we have a triangle, theta, right? So, unit circle basically just means that all the points are like 1 unit from the center. So, this line would always be 1. So this side here would be sine theta. This side would be cosine theta. And as you can see, just using the Pythagorean identity, sine squared theta plus cosine squared theta should equal 1. Right, because it's a right angle triangle, just because of how it looks like. Double angle identities. I mean, if you know the double angle identity, it's probably better to just know the compound angle identity anyways. It's especially if it's on your formula sheet, right? So say sine A plus B equals sine A cosine B plus sine B cosine A. And you only really have to know the positive version, because let's say if B was negative, you just sub in the negative B here, cosine is an even function, so cosine negative b would equal cosine b. So the sign of cosine b stays the same. But sine is odd, so this becomes negative, and so sine of a minus b, or a plus negative b, so sine of cosine b would stay the same, but the sign of sine b would change. So sine b would become negative sine b cosine a. Same with the cosine identity. So cosine a plus b. So that is cosine a cosine b minus sine a sine b. Same thing. If you want the subtraction, just swap b with negative b. Cosine is even, so cosine b's sign is not going to change. Sine b is an odd function, so sine negative b would be negative sine b. So then it would be a plus here. So you can see. But it's all on your formula booklet, so you really shouldn't have to memorize it. Tangent a plus b, it's pretty much the same thing. Like the way you derive this is you just put the sine above the cosine, and you literally just expand this out. You just literally put this on top of this in a fraction, and then you cancel some things out. Same thing for tangent. You just change both of these to the same thing. One thing that I would say you might want to know is the sum to product identities. Sum to product. I know it's not in the curriculum for SL or HL, or sum to product and product to sum identities. So many. I don't want to write them wrong. So yeah. So there you go. So sum to product identities. Basically, the sum of two trigonometric functions can always be written as a product of two trigonometric functions. And same thing in reverse, right? Not something that you really need to... I wouldn't say not something that you have to know, but it's definitely good to know. The derivation isn't too difficult. But I can go over that on another day. Okay. Can I go over logs? Yeah. So logs, let's see. Go over here. So logs and exponents. And I think it would be more helpful if you guys have like any questions that you want me to explain. Like I can go over those. Okay, so it's pretty important to know your exponent rules. But let's just say that you know all of them. And logarithms are basically a way to know the exponents given the base number. So let's say you have a to the power of n equals b. Then how can we know what n is? Well, we take the logarithm of b with respect to a, and that would give n. Let's see what you have to know for logs. Is that all it is over here? Okay, I guess that is all it is. That's not a lot, honestly. Okay, well, I can explain these identities in a bit more detail. So, first one is the log a xy. So this is equal to log a x plus log a y. Realistically, the way you want to think about this is, let's say x was like a to the power of, let's say b, and y was a to the power of c. So just some powers of a. So log ax would obviously give b. Same with log ay, that would give c. Now the reason why they can just, or like x and y kind of just multiply when you put them in the log, is because let's see what you get when you get log a xy, right? So this is equivalent to log a to the b times a to the c, and that's log a to the b plus c, which is b plus c, which is what you have up here. So essentially, since when we multiply exponents of a, the exponents are added, so you can think of logs as like exponents, right? The reason why like they multiply is because we add them after we multiply powers together. Same with this. So when you subtract, you divide. Another one is log a x to the n equals n log ax. So this one just kind of comes from the identity up here. If you have like n log ax's, so let's just say like log ax plus log ax plus log ax plus log ax, and you had like n of them, then when you sum them together and you want to write it as one log, remember when you're adding logs together, you have to multiply all of them, right? So that would be log a x to the power of m. So you multiply all the x's together. The formulas not go over change of base. That's pretty weird. So doesn't go over base change formulas. Okay. Well, okay, I'll just write them down. So let's say you have like log AB and you want to change the base, right? You want to change A. What you can do is you can multiply this by like log AC over log AC. So you're multiplying by 1. And so what this would give is log AB over log AC times log AC. Now, when you get this sort of thing, the log A essentially cancels out log, so this turns into log CB times log AC. So if I were to write it this way, it's probably easier to see. Log AC times log CB. You can think of logs as like kind of like a chain where this thing can kind of cancel out with this thing when they're being multiplied together. So the C here will kind of just cancel out with the log C. So pretty much this would be log AB, which is what you had at the beginning, right? So if you want to write log AB using a different base, you can write it as log AC times log CB. Another really useful tip that I find that like a lot of like math classes that they don't actually teach you with logs is that log, okay, this is going to get a little bit messy, but log a to the n, or log ax, is equal to log a to the n x to the n. So you can actually take a power of the base and the and what's in the log together, and that will actually be the same thing. So this is very useful when you have like a question, say like log, or like you have log 2 something plus log 4 something plus like log like 32 something equals blah blah blah. And you want to change, so obviously your goal is to change everything into the same log. Like a more intuitive way would just be like take the square root of this, right? So that would be like log to b to the 1/2. This would be log to c to the 1/5, right? And then since they're logs, you can drop these exponent to the front, so that would be just 1/2 log 2b and 1/5 log 2c. So there's obviously other ways that you can get the same results, but this is just what I find an easier and more intuitive way of like simplifying logarithms. Okay, so we have a request for a question. I'll put it on the screen. Consider the 6th degree polynomial fx equals 20x to the 6 plus ax to the 5 all the way to 140, where a is an integer. The zeros are log m n squared, log m squared n cubed. Was this question on a previous SL test? Was this question on a previous SL test or something? It looks kind of familiar to me. Oh, it was on the HL test? Okay, well, how much of functions do you guys know? Saw something similar on RV? Yeah, so do you guys know Vieta for so Vieta's theorem for like higher degree polynomials? So Vieta for higher degree polynomials. Oh yeah, this is actually something that I wanted to get into. With functions especially. Yeah, this is a pretty good question. Okay, so let's see what's on your formula booklet. Functions. Oh, okay. Sum and product of the roots of polynomial equations. Oh, okay, so it told you this. Okay. So this is pretty much Vieta's formula for higher degree polynomials. Yeah, so right here. So when we have a function that looks like sigma r equals 0. So basically a0 x0 plus a1. So let's say like f, or maybe not fx, we'll call it gx. equals a0x0 plus a1x plus a2x2 all the way to anxn. So as it told you, the sum is negative, or the sum of all the roots is negative an minus 1 over n. So the sum is negative an minus 1 over an. I thought you like do a bunch of logs, change base, and then cancel. Yeah. So in this question, you definitely want to change the base, because in the end, from this, you know, you can find, you can express the sum of the roots, right? Using that. So in this case, an would be 20, x to the 6. An minus 1 would be ax to the 5, right? So in this case, the sum would just be negative a over 20, right? And you want to now you basically you can write an equation using negative a over 20, and you equate that with the sum of all the roots here. So basically you have another condition that says s equals the sum of all the roots. So log m n squared plus log m squared n cubed plus log, oh, that's weird. Okay, so log m cubed n to the 4 plus log m to the 6 n to the 7. So using the way of simplifying the logs that I just told you, so log m n squared plus, so I can take the square root of both the base and the number inside. So I would get log m in 3 over 2 plus log m in 4 over 3 plus all the way to log m in 7 over 6. Right, I'm taking, like, basically from this one I'm taking the 1/2 power. This one I'm taking the 1/3 power of both the base and the number. This one I'm taking the 1/6 power of both the base and the number. So then I will get 2 log mn plus 3 over 2 log mn all the way to 7 over 6 log mn. So once again, change of base. Now you can sum them all together. So log mn, so this is log mn times 2 plus 2 over 3 plus 3 over 4 plus 4 over 5 plus 5 over 6 plus 6 over 7. Ah, okay. So that's, okay, yeah, I see. So you do a bunch of logs, change the base, and then cancel. Right, yeah, so you're on the right track, but in this question, we have, okay, if you just take a look at this equation, right, we have, or like, if I were to equate this to m, which is negative a over 20, I have 1 variable, 2 variables, 3 variables. That's way too many for me to solve, right? I can't solve this equation. I can't solve for a just given this much information. I need more information. So you're on the right track with finding an equation for the sum of the roots. The next step is to notice why they gave us 140, right? They wouldn't just give us the last term, or a0 in this case, without any reason. So if we take a look back at the formula booklet, we know that the product is negative 1 to the power of n, a0 over an. So I'll write that over here. So product equals negative 1 to the n, a0 over an. Oh, so basically the idea here is you want to solve for log mn using what you know from the products, because you actually have a numerical value for the products, right? The products only call for a0 and an, which are both values that you know in this question. So you can solve for log mn using the products. And then, once you find log mn from this equation using the products, you sub it back into this equation, and since you know log mn, you can find the value of a. So that's the whole idea. Right. Yeah, so I'll just finish this question out then. So -1 to the n a0 over an. So that would be, so -1 to the 6. A0 is 140 and an is 20. Times 140 divided by 20. This is just 7. And another way we can represent the products is using log mn times log m, or log mn squared, log m squared n cubed times log m to the 4 n, or log m cubed n to the 4 times all the way to log n to the 6 n to the 7. And you basically do the same thing, right? You represent these all as log mn. You can solve for log mn using this, because you know that the product of the roots is 7. You can solve for log mn using that. You sub back in for log mn, and you solve for negative a over 20. That's pretty much it for this question. Okay, Chris, are you still there? You still want to go over counting? All right, well, I guess that's most of the questions answered. So if you have any more questions, you can send them to me, or you can just text in the chat. Okay, so question about Bayes' theorem. To be honest, I think Bayes' theorem is an absolutely stupid concept. Like, when you're actually doing the question, you're never actually going to use it. Like, genuinely. And realistically, it's never gonna make you write out this formula. Like, it's never gonna make you write out this formula. But well, since it's there, well, the point of Bayes' theorem is basically saying it's a way to like express conditional probability. So it's probability once we're given a condition. So if we go back to the problem that we had here, yeah, so this question here, there are 100 boys and 120 girls in the grade 12 year. 20 boys and 30 girls have no siblings. A student is randomly selected. What is the probability that the students have no siblings? Well, that would be 50 because 20 boys and 30 girls have no siblings over the total, which is 220 because that's the total, right? In this question in part A, there's no restriction on what the total can be. So therefore the total is just the total amount of people that we're choosing from. But in part B, the student is chosen who has no siblings. The student is chosen has no siblings. So that's our given condition. So that's the conditional part of conditional probability in this question. So we're given that the student has no siblings. Therefore there's only 50 people that could have been chosen. Therefore, the total number of people that the total number that's going to be in the denominator has to be 20 plus 30, which is 50, because those are all the people that actually fit this condition. So in this question, we had a condition, right? The condition basically says that the student chosen has no siblings, and that forces the total to just be 50. And then it asks what's the probability that the student is a girl. Well, there's 30 girls, so 30 out of the 50. And what Bayes' theorem is basically saying is like this giant formula. I'll copy it just for the sake of it. But realistically, personally, I never memorize this. Like, it's usually more simple to just go off logic. What it says, it's pretty much like the probability of B happening given A happening. So in this question, that was the probability of B happening was the chosen student was a girl. And the probability that was given, which is A, which is also the condition, is the student had no siblings, right? So you can use this like massive formula that they gave you, or you can just do it logically, right? Given that the student had, given that the student has no siblings, which we had 50 students in total. Out of the 50, only 30 of them would have been girls. Okay, I'll stay on for a few more minutes to answer any more questions. All right, so we'll go over inequalities. So solve the following inequality. Absolute value of 4x plus 3 smaller than x minus 2. So with absolute value inequalities, you usually have to do casework. And you usually do casework based on when the sign changes. So in this case, the sign changes when 4x plus 3 equals 0, or 4x equals negative 3, or x equals negative 3 over 4. So we have to do two cases, one for x is smaller than negative 3 over 4, and one for x is greater than negative 3 over 4. So we'll do case 1, x smaller than negative 3 over 4. So we can plug that in. Now, when x is smaller than negative 3 over 4, the absolute value inside would be negative, and therefore what comes out of the absolute value would be negative 4x plus 3. That is smaller than 2 minus x, so negative 4x minus 3 smaller than 2 minus x, which is just negative 5 smaller than 3x, x greater than negative 5 over 3. So yeah, so in this range, that would this actually does suffice for a certain amount of values. So this gives a range. So make sure at the end you combine these two conditions. For the second case, so now x is greater than or equal to 3 over 4. Now whatever's in the absolute value is positive, so we just have 4x plus 3 smaller than 2 minus x. Or 1 is smaller than negative 5x. Negative 5x is greater than 1. Divide by negative 5, so x is greater than negative 1 over 5. The sign changes since we're dividing by a negative number. Now, once again, so x greater than or equal to negative 3 over 4, smaller than negative 1/5. Once again, there is a range, but make sure to take both conditions into consideration. Finally, we can merge these two conditions, and that would give x greater than 5 over 3, smaller than negative 1/5. All right, any more questions? Okay, I'll share the link once again so anyone can see. You guys can see it after. But if there are no more questions, I'm gonna end the stream soon. Alright, yeah, okay. I think that's it. I'm just gonna end the stream here. Alright, yeah. Thank you everyone for coming. If you're still here and you sat through the whole thing, yeah. Alright. Logging off. See you guys. Peace.